name is Joseph Zidane, and I will be giving a presentation on my feasibility report. So some background information. In the U.S., alternating current used to be superior to direct current for almost all domestic, industrial, commercial supplies for electricity. That is not the case anymore. With the changes in technology over the last 20 years, we are in need of a cleaner, more efficient power source such as direct current. The purpose, we will find out if it is more practical to be using a different source of power transmission than we have been using for the past century. I am hoping to make the switch to DC power transmission nationwide. The feasibility question answered is transmitting power over long distances, which is more efficient, AC or DC. Scope, I will be covering the cost of changing existing towers, changing existing AC towers to DC towers, and the factors to consider. Also look at the advantages and disadvantages of AC and DC transmission, and lastly look at the impact of the implementation and how it would change the movement of high voltage power for the better. Cost of implementation. An important part of the decision-making process is the cost of alternative DC and AC solutions. In addition, the operational expenses advantages that are obtained from each of these options should be considered carefully and assessed so that the probable total investment in operating costs can be approximated. The implementation of the solution would be significantly more expensive if we did not take these factors into account. So factors to consider. For the DC transmission, we must consider funds for the converting terminals, AC input and output equipment and facilities, the ground electrodes, and the interconnecting transmission line must be evaluated, as well as the cost of converter and transmission line losses. For the AC transmission, we must consider the installation cost of the step-up and step-down transformers, the overhead line, light load comparison, circuit breaker buildings, and development sites. So on the screen here, I have a chart or a graph. It represents distance in kilometers and cost in dollars of the ratio between alternating current and direct current. So high voltage alternating current leads till the break-even point, which is this little black line. That's about 600 kilometers. After that, before that, the cost over distance is cheaper, and after that, HVDC is more cost efficient. Benefits and drawbacks of AC and DC transmission. AC and DC are both used today in work for power transmission. They have their own advantages and disadvantages. I've listed some of the advantages and disadvantages I thought were important. There's a lot more in my report. So overall, DC transmission has more advantages over AC, but we continue to use AC nationwide. Impact of the implementation. Direct current electric power is an emerging disruptive technology area that has the potential to stimulate economic growth, inspire innovation, increase research and development opportunities, create jobs, simultaneously advance environmental sustainability. DC technology applications offer the promise of enhancing energy efficiency, improved power quality, and reliability. DC power is beginning to evolve towards replacing AC, a nationwide standard of electricity delivery infrastructure in many applications. So some practical uses. New transmission lines for major wind solar farms are planning stages in the Midwest and the U.S. The Midwest and Western U.S., sorry. The U.S. and Canada already have approximately 20 operational HVDC sites. HVDC transmission is cheaper than AC at a certain distance of power delivery. That's what the graph I had was explaining. The world went to AC at the turn of the century for a variety of reasons that are relevant today. The case for investing in DC infrastructure is strong today due to both economic factors and sustainability factors. So in conclusion, I believe nationwide we need to bite the bullet and make the implementation of AC to DC. Like I said, we need more and more power everyday life. Main issue is moving large amounts of voltage over long distances. DC is becoming more popular because of the implementation. In the long run will be cheaper. In addition to inspiring economic growth, increasing innovation, increasing work opportunities, and advancing environmental sustainability, DC electric power is also a emerging disruptive technology area. So some recommendations I have, so obviously changing AC to DC power transmission, and we can do that by taking the existing power lines and converting them to DC, and I mean, we can get rid of them. We can take those lines and put them underground as well. So next one is converting AC terminals to DC terminals, getting rid of AC transformers completely and putting in the DC motors. So these AC motors have a spot where they're sitting ready, so we can take the DC motors and just replace them. Getting rid of AC conversion steps through renewable energy, so wind and solar. So we can take the renewable energy, tie it straight into the DC terminal, and go to the distribution terminal, and completely skip the conversion step. And that is all I have. So thanks for listening, and if you have any questions, you can leave it in the comments or contact me directly. Thank you.